Hi everyone, welcome back to my YouTube channel. So today we are going to talk about an array queue, which is a simple but powerful data structure. So without further discussions, let's get into the video. So what is an array queue? It's a linear data structure that follows FIFO principle, which means first in, first out, and it implemented using an array. And there are two main operations as NQ and DQ. NQ means adding an element, DQ means removing an element. So next, let's see how an array queue works. Elements are added to the rear of the queue and elements are removed from the front of the queue. And the front moves forward after each removal of element, and if the queue is full, no more elements can be added. And let's see what are the real life scenarios associated with array queues. As you can see in these pictures, ticket counter, right? In the ticket counter, first person in line served first, and we can see a call center queue and also the printer. These are the real life scenarios, and here are some snippets, code snippets related to array queues. Let's see. The first one is initializes an empty queue with a fixed size. So first the front is 0, front is assigned as 0, and it points to the first element in the queue, and the rear is -1, which means the queue is empty, and the size of this queue is 0, and it keeps track of how many elements are in the queue, and the capacity of this queue is 5, which means maximum number of elements the queue can hold. And you can see there's a line called queue, which means the array that store queue elements, and next, this code snippet is adds an item at the rear. In this snippet, it check if the queue is full, and if size equals to the capacity, it prints queue is full and it stops, and after that move rear to the next position. You can see that as rear plus 1 modulus capacity. This code line helps to move rear to the next position, and if rear reaches the last position, modulus make it wrap around 0, which means a circular queue. And in this code snippet, you can see this final line, and it helps to increase the size, which means size plus plus. Also, there's this line queue rear equal item. This helps to store the new item in queue. And the third code snippet is remove the front item, and it check if the queue is empty, and if size equals 0, it print queue is empty and stop, and then it retrieve the front item and store it in item, and move front to the next position using this modulus. And if front reaches the last position, modulus wrap it back to 0. And you can see size minus minus, which means it decreases the size. And return item means it return the removed item. So the fourth code is returns the first and last elements, and there's a method called getFront. It helps to return the first element, and there's another method called getRare, which means returns the last element. And if the queue is empty, which means size equal 0, it return -1 instead of an error. And finally, we're going to talk about the importance of an array queue, and it helps for an efficient data handling. And when we talk about data handling in real life applications like scheduling and buffering, and FIFO order ensures fairness, as elements are processed in order. First person serves first, and simple implementation. When we talk about simple